January 1944. Snow fell like ash over the Ruhr Valley, coating the chimneys, the railway yards, and the skeletal frames of half-finished Messerschmitt fuselages. Inside the steelworks of Essen, hammers still rang through the smoke, sparks bursting against the soot-streaked walls. But even as the furnaces roared, German engineers could feel a strange pressure tightening around them, something they could not yet name. It wasn't a single bomb or battle. It was a shadow stretching across the Atlantic, forged not in Berlin or Munich, but in Detroit, Pittsburgh, and Buffalo. Months earlier, in the offices of the Reich Ministry of Armaments, Albert Speer had assured Hitler that Germany could still win a war of production. The Führer listened, pacing, convinced that quality would outweigh quantity. Our tanks, our guns, our planes, superior in every respect, Speer insisted. The charts looked convincing. Monthly output of 1,500 aircraft, 600 tanks, and 20,000 tons of ammunition. But the paper numbers hid a darker truth. Outside the Reich's borders, in sprawling cities untouched by bombers, America had begun to move in ways the German High Command had never imagined. By early 1942, Roosevelt's Arsenal of Democracy speech had already been translated and analyzed in Berlin. Most officers dismissed it as political theater. After all, how could a nation of consumers, still climbing out of the Depression, match the discipline and efficiency of the German war machine? Yet by the end of that year, the first signs were unmistakable. Entire American cities were transforming into weapon forges overnight. Detroit's automobile lines were retooled into tank plants. Ford's Willow Run factory rolled out AB 24 bomber every 63 minutes. At the Douglas Aircraft Works, women in kerchiefs and men in coveralls swarmed aluminum skeletons by the thousands, their hands synchronized with conveyor belts that never slept. The Luftwaffe's intelligence division began receiving aerial reconnaissance of strange factory complexes in Michigan, Kansas, and California, facilities that had not even existed before the war. Reports describe rivers of steel moving by rail, oil pipelines feeding into endless assembly halls, and shipyards producing Liberty ships faster than German engineers could draft blueprints. To Berlin's planners, it seemed impossible. Their doctrine of blitzkrieg had relied on lightning offensives, quick victories, and precision weapons. No one had ever prepared them for a world where the opponent could simply build faster than destruction itself. In 1939, the United States had ranked 17th in military production. By 1943, it surpassed the combined output of Germany, Italy, and Japan. The figures were staggering. American factories produced 86,000 tanks, 300,000 aircraft, and 2.5 million trucks over the course of the war. The scale defied imagination, trainloads of parts stretching beyond sight, cranes lifting turret shells the size of small cottages, welders blinded by sparks that lit entire hangars. Each day felt like another tide rolling across an ocean of metal. German industrialists like Krupp and I.G. Farben had prided themselves on craftsmanship. Their factories were masterpieces of precision, workers trained for years to machine tolerances within microns. But those same methods became shackles. Where an American line worker could swap a jig and produce thousands of identical parts in hours, German plants still required adjustments by hand. Engineers debated tolerances, argued over alloys, and clung to perfectionism as the skies above grew darker with Allied bombers. The very culture that had given Germany engineering dominance was now dragging it under. Speer's ministry scrambled to adapt. He ordered decentralized production, dispersing factories into forests and tunnels to evade air raids. But decentralization came at a cost. Disconnected supply chains, redundant labor, and chaos in transportation. Coal shipments stalled. Rail lines shattered. Communications lagged behind the bombs. Meanwhile, America's logistics web functioned like a living organism. Trains, barges, and trucks pulsed from factory to front line in seamless rhythm. Engineers at General Electric, Bethlehem Steel, and the U.S. Army Corps of Engineers worked as if part of one colossal machine, anticipating shortages before they occurred. On the ground, the difference was felt in every theater. In North Africa, German tank crews scavenged for spare parts while American mechanics replaced entire engines overnight. At sea, U-boats sank Liberty ships faster than Britain could build them, until American yards ramped production beyond comprehension. Soon, new hulls replaced losses in mere weeks. To a German admiral studying the Atlantic reports, it looked as if the Allies possessed infinite resources. For every ship we destroy, one officer muttered, 3 more appear the next morning. But it wasn't only about numbers. It was rhythm, the relentless tempo of industry. In Chicago, machinists worked 12-hour shifts under floodlights. In Seattle, the Boeing assembly floor glowed to the night, like a cathedral of rivets and noise. Even Hollywood joined the effort, producing training films and propaganda reels that fueled morale as much as production itself. The country had found a new faith, not in conquest, but in manufacture. By mid-1943, the German Air Force began bombing its own doubts away. Speer's reports to Hitler still promised recovery, but secretly, he knew the truth. American aluminum output alone now equaled the entire German aircraft industry. U.S. factories had turned the abstract concept of total war into a mathematical certainty. They could lose 10 tanks and build 20 more by the end of the week. German tank commanders began to notice the imbalance firsthand. After the battles of Kursk and Tunisia, wreckage told the story. American M4 Shermans, arriving faster than German crews, could reload their 88s. In a secret conference, Hermann Göring raged at his industrial chiefs, accusing them of incompetence. You let them flood the sky with planes, he thundered. But no amount of shouting could conjure aluminum or manpower. The Reich's industrial heart was bleeding out under the weight of strategic bombing and fuel shortages. Workers, exhausted and hungry, assembled Panzer parts in candlelight, their breath fogging over the steel. In contrast, across the ocean, American workers enjoyed hot meals, union wages, and swing shift dances before returning to the lines. It was not just production, it was morale, momentum, and belief. Still, Germany clung to hope. New weapons like the Tiger tank, the V-2 rocket, and the Me-262 jet promised miracles. The propaganda reels declared that advanced design would overturn mass production. But even the most brilliant inventions required factories, and those factories were vanishing under bombs and shortages. Engineers could draft blueprints for wonder weapons, yet without the raw materials, they remained fantasies. As 1944 approached, German strategists looked again at the intelligence reports. The numbers coming out of America no longer seemed real. Shipyards launching freighters daily, ammunition plants filling millions of shells each week, and aircraft factories rivaling entire nations in output. They had underestimated not only American capacity, but American will. By spring, whispers spread through German industry. Quiet confessions that the war might already be lost, not on the battlefield, but in the foundries. The Reich had built its empire on speed and precision. The Allies had answered with scale and endurance. And in the roar of those endless American assembly lines, the sound of Germany's fate was already being hammered into shape. In the spring of 1944, deep within the Ford Motor Company's Willow Run complex, a single phrase defined the mood of American industry. Keep it rolling. The slogan wasn't propaganda. It was a commandment. Every hour, the great assembly hall thundered with sound. Rivet guns snapping in sync, engines humming across endless conveyor belts, and foremen shouting over the roar of compressors. From one end of the mile-long building to the other, the skeletal frame of AB 24 Liberator bomber traveled like a living organism being born. By the time it reached the sunlight of the hangar doors, its wings gleamed under fresh paint, engines tested, guns mounted. The workers cheered as it lifted into the sky, another metallic bird feeding the skies of Europe. The hidden advantage that stunned Germany wasn't a secret weapon, it was a system. The United States had mastered industrial synchronization, an idea first envisioned by engineers like Charles E. Sorensen, who once managed Ford's automotive assembly lines. Sorensen and his peers adapted mass production into modular warfare manufacturing. Factories didn't just make products, they made the machines that made the products. Specialized plants built parts in precise standards, propellers in Connecticut, engines in Michigan, fuselages in California. Each piece was interchangeable, fitting perfectly when shipped to final assembly lines. Germany's engineers, accustomed to precision craft, were trapped by their own perfection. Their factories couldn't replicate parts at this speed. Where German workers machined tank armor plate by hand, American engineers devised automatic cutting presses and welding jigs. Bethlehem Steel developed rolling mills that shaped armor sheets in minutes, not hours. The U.S. Army Ordnance Department introduced statistical process control, a technique pioneered by mathematician W. Edwards Deming, ensuring every M4 Sherman rolled off the line with near-identical reliability. German engineers, reading capture reports, were baffled. The enemy had transformed warfare into arithmetic. Behind the scenes, a coalition of minds made it possible. William Knudsen, an immigrant from Denmark who once built Chevrolets, became Roosevelt's industrial commander. Alongside him stood Henry Kaiser, a construction magnate who promised to build Liberty ships faster than the U-boats can sink them. His secret? Prefabrication. By dividing a ship into 250 separate sections, Kaiser's shipyards turned an 8-month job into 8 days. Welding crews, men and women both, assembled hulls like puzzle pieces under floodlights, the night echoing with torchlight and steam. German naval intelligence initially dismissed reports of these feats. "No ship can be built in a week," one admiral scoffed. Then came the proof. Photographs of entire convoys leaving American ports, fresh paint still drying on their bows. Even the famed Kriegsmarine construction yards at Kiel and Hamburg couldn't produce destroyers or U-boats at such a rate. The German engineers at Blohm Voss realized, too late, that industrial rhythm had become a weapon of its own. In tank warfare, the contrast grew even sharper. The American M4 Sherman, derided by many for its thin armor, represented the pure embodiment of logistical warfare. Each tank shared common parts with trucks and artillery tractors. Its 75mm gun could be replaced in the field, its engine swapped within hours. The Germans fielded magnificent machines, the Tiger Eye, the Panther, the Elephant, but each was a masterpiece of over-engineering. Components were hand-fitted, requiring skilled labor and extensive maintenance. When the Wehrmacht's 503rd Heavy Panzer Battalion faced the Allies in Normandy, their Tigers destroyed dozens of Shermans, but soon found themselves immobilized. Without spare transmissions or fuel, the invincible tanks became immovable fortresses. Inside U.S. Logistics headquarters in London, officers studied production numbers like battlefield maps. For every Tiger destroyed, American factories could build 10 new Shermans. The numbers grew merciless. 49,234 Shermans by war's end, compared to roughly 6,000 Panthers. Engineers like Clarence Kelly Johnson at Lockheed and Edsel Ford at Willow Run ensured that replacement parts, ammunition, and fuel followed every frontline advance. Supply was no longer a problem to solve. It was a battlefield itself. On the air front, the same pattern unfolded. Germany's aircraft industry, once the pride of the Luftwaffe, struggled under Allied bombing. Factories were scattered, workers displaced, transport crippled. Meanwhile, across the Atlantic, American production had become nearly automated. At Boeing's Plant 2 in Seattle, for parallel lines produced be 17 flying fortresses under controlled lighting and precision tooling. The U.S. Army Air Forces demanded 5,000 aircraft a month. Engineers redesigned processes until they achieved it. By mid-1944, American skies swarmed with aircraft bound for England, waves of aluminum that darkened the horizon. German officers watching from coastal outposts couldn't comprehend how such volume was possible. In one intercepted letter, a Luftwaffe technician wrote, "Every time we shoot down 10, 20 more come. It's as if they grow on trees." His despair wasn't poetic exaggeration. It was fact. For every pilot Germany trained, America trained 10. For every aircraft lost, America produced 10 more. The balance sheet of war had become irreversibly one-sided. But even this tidal wave of production required brains as much as steel. The Office of Scientific Research and Development, OSRD, linked university scientists to industry, bridging physics and assembly lines. Radar, proximity fuses, and synthetic rubber, all product of academic collaboration, were scaled for mass production through contracts with General Electric, RCA, and Goodyear. The German war economy had brilliant scientists but lacked this coordination. Werner von Braun's rockets, though extraordinary, drained resources rather than multiplying them. Meanwhile, back at Willow Run, engineers tracked their progress like soldiers charting an offensive. "We're winning by inches of steel," one supervisor remarked. Across the continent, the same spirit pulsed. Shipbuilders in San Francisco, aircraft workers in Tulsa, and tank crews in Chicago shared one mission: outbuild, outlast, and overwhelm. Germany tried to adapt, launching Speer's emergency armaments program. He consolidated production, introduced assembly lines, and forced output gains of nearly 30 in 1944. But by then, the gap had grown too wide. American factories had momentum measured not in percentages, but in magnitudes. The technological depth of U.S. industry revealed itself at every layer. Electrical wiring harnesses for bombers were prefabricated and tested before installation. Subassembly kits for tanks were boxed, labeled, and sent directly to ports. Even paint formulas were standardized to dry faster under humidity. Every innovation multiplied speed. German intelligence officers, poring over captured manuals, marveled at the precision of logistics diagrams. To them, it seemed less like warfare and more like a kind of industrial choreography. In the final months before D-Day, the American supply chain reached its crescendo. From New York to Liverpool, Liberty ships steamed in unbroken convoys, holds packed with the tools of invasion: rifles, tanks, rations, boots, field radios, and gasoline. Every crate bore a stenciled code, every code traced to a factory ledger. When the beaches of Normandy erupted on June 6, 1944, the soldiers who landed carried the invisible weight of millions of factory hands behind them. And in Germany, inside Speer's war ministry, the realization finally struck with brutal clarity. For all their engineering brilliance, they had been fighting an opponent whose true weapon was not innovation, but organization. America's factories weren't just producing machines. They were producing inevitability. By the summer of 1944, production ratios told the whole story. For every German plane, 10 American aircraft. For every German tank, 10 Allied vehicles. For every ton of ammunition, 10 tons waiting in Allied depots. It was not just numbers. It was the sound of an empire's heartbeat slowing. And as the thunder of Allied convoys filled the Atlantic, a new kind of warfare had emerged, one where victory was measured not in bullets fired, but in engines built. By late 1944, the psychological impact of America's industrial dominance was rippling through every corner of the war. For German soldiers on the front lines, it was no longer a question of courage or tactics. It was endurance against an enemy that never seemed to run out. Tanks burned in the Ardennes, and within weeks replacements rolled ashore. Bridges were bombed in France, yet fresh steel arrived by rail to rebuild them. Even the Luftwaffe's most daring efforts to strike Allied supply lines collapsed under sheer replacement power. To the German mind, trained to equate precision with superiority, the scale of American replenishment seemed like a kind of sorcery. In Allied headquarters, however, this momentum was carefully engineered. General George C. Marshall had built a supply system as complex as an army itself. Under him, logistics became a doctrine. Every rifle, every shell, every radio had a place in a vast, interconnected web. Quartermasters forecast consumption months in advance, drawing data from depots across 3 continents. Factory engineers collaborated with frontline officers, refining packaging, durability, and fuel efficiency. What had once been considered rear support was now an offensive weapon. The results were visible in the autumn of 1944. As the Allies prepared to breach the Siegfried Line, Eisenhower's staff calculated that for every American division in combat, 3 divisions' worth of equipment and reserves stood ready behind them. Trucks, nearly 2.5 million of them, formed what soldiers called the Red Ball Express, a highway of motion carrying ammunition, food, and fuel from Normandy to the Rhine. The convoy drivers, many of them African-American servicemen, kept the flow alive 24 hours a day. The German army, by contrast, relied increasingly on horses. The Wehrmacht, in its final year, operated more horse-drawn wagons and mechanized vehicles. A bitter regression for a nation that once defined modern mechanized warfare. Inside the Reich, the psychological toll was devastating. Civilians queued for hours as ration lines stretched down frozen streets. Bombing raids flattened factories faster than Speer's engineers could rebuild them. Workers slept in tunnels, their breath fogging over half-melted machinery. For the first time, Germany's propaganda machine began to lose its voice. Speer's speeches about miracle weapons fell flat against the reality of starvation and exhaustion. Even Hitler, reading the latest armament figures, could no longer deny the arithmetic. The United States had become a continental forge too vast a challenge. In January 1945, as American armored columns surged into Germany, Allied analysts released preliminary data that stunned even them. U.S. production had exceeded all projections. Over 300,000 aircraft, 120,000 naval vessels, and nearly 90,000 tanks had been built in less than 4 years. Behind each figure lay an army of engineers, welders, and machinists who never saw the front lines but shaped its outcome. Men like Charles Sorensen, Henry Kaiser, and William Knudsen, industrial generals whose weapons were organization charts and assembly lines, had achieved what no battlefield commander alone could: victory through volume. For German engineers, this realization was soul-crushing. Many were interrogated after the war and spoke with disbelief about what they had faced. A captured production chief from Messerschmitt admitted, "We thought the Americans were slow, clumsy people. We never understood their factories were the battlefield." That statement reflected more than arrogance. It captured the collapse of a worldview. German industry had believed excellence resided in mastery of craft, while America had redefined excellence as mastery of scale. Even among Allied commanders, there was awe. General Omar Bradley described American production as a flood tide, bigger than any general's plan, impossible to turn back. The same sense of wonder extended to the home front. Newspapers printed photographs of women riveting aircraft wings, of shipyard welders working under blizzards of sparks, of farmers turning over tractors to the war effort. It wasn't just output, it was unity. Factories in the Midwest and ports on the coast were bound together by telegraphs, contracts, and shared urgency. The arsenal of democracy had become a national identity. For Germany, the defeat was not only material but spiritual. In underground bunkers, Speer continued to promise miracles that never came. The V-2 rockets launched from Holland fell on London, but each missile cost more than a fighter plane. Jet aircraft like the Me-262 could have changed the air war, yet only a few hundred were completed. Germany still had genius engineers, but without resources, genius became irrelevant. By contrast, American engineers thrived in abundance. They could experiment, fail, and rebuild within days. Mistakes became fuel for innovation. The shockwave of this industrial revolution extended far beyond the war's end. When Germany surrendered in May 1945, Allied investigators cataloged the wreckage of its factories. What they found confirmed a truth long suspected. Production had collapsed months before the front did. Coal shortages, shattered rail lines, and worker fatigue had crippled output. Even the vaunted Krupp and Daimler-Benz works were operating at less than a quarter of their capacity. Meanwhile, America's factories were already converting for peacetime, ready to flood the world with cars, refrigerators, and jet aircraft. Psychologists studying post-war Germany noted the despair among former engineers and factory managers. Many spoke of humiliation, not merely from defeat, but from being outbuilt. "They buried us in machinery," one technician said during an Allied interview. It wasn't propaganda. It was the simple truth of industrial warfare. Germany had fought an army. America had mobilized a civilization. The legacy of that mobilization defined the century that followed. During the Cold War, the same logistical logic that overwhelmed the Third Reich became the backbone of American strategy. The Pentagon's planning systems, the interstate highways, even NASA's rocket programs all grew from wartime coordination between science and industry. Wernher von Braun, who once designed rockets for Germany, now worked for the country that had proven the supremacy of organized industry. For the soldiers who lived through it, the lesson was clear. On the front lines of Europe and the Pacific, they learned that courage without supply was suicide. and that innovation without mass meant failure. American engineers had proven that the decisive weapon of the modern era was not a tank, plane, or gun, but the assembly line. In 1946, as the war statistics were published, one report from the U.S. Strategic Bombing Survey summarized the imbalance in stark numbers. The United States had produced 10 times the war, material of Germany by volume, while maintaining domestic prosperity and morale. Economists called it the victory of scale. For veterans, it was something simpler, the miracle of never running out. And so, when historians later debated whether D-Day, Midway, or Stalingrad marked the turning point of World War II, a quieter truth persisted among those who understood the machinery behind the front. The war was won the moment America learned to outproduce destruction itself. Factories, not fortresses, had decided the fate of nations. Blueprints had become battle plans. Riveters and welders had become soldiers of steel. The hum of engines, the clang of presses, and the rhythm of assembly lines had become the drumbeat of victory. In the end, the greatest secret weapon of the Second World War wasn't hidden in a laboratory or a bunker. It was the American factory floor, lit by floodlights, echoing with noise, filled with ordinary men and women turning raw material into destiny. And long after the guns fell silent, that lesson remained etched in history. In modern war, the power to build is the power to win.